1, 2. 1, 2. Hello. Hello, everyone. Can you hear me? I assume you can. Okay. So if you can hear me, that probably is fine because just my computer said my audio is not very good, but apparently it is. Anyways, today, so I am very sorry that I still haven't published maths. It is almost ready. Today I will show you the draft. So it's pretty much finished. So here it is. The topic is simultaneous equations. I'm going to share my screen, and in a minute you're supposed to see something. Okay. Computer's being a bit slow. Okay. Can you see my screen? Can people see my screen? Hello. Somebody? Can people hear me? Oh, yes, you can hear my screen. See my screen. Okay, good. So the assignment is published here. So, well, it's not officially published, but this is a draft version. So it's due on the 17th of March. So you got 3 weeks, 3.5 weeks. The topic is simultaneous equations. And we're talking about different methods of solving simultaneous equations. So simultaneous equations, also known as systems of simultaneous equations. And sometimes you will have 3 variables. So slightly harder than the stuff you are used to in school, but yeah. I'm going to show you different methods of solving simultaneous equations today. And yeah, so some of them would be quite easy, some of them would be quite tough. So let's dive into that. So what are simultaneous equations? Well, simultaneous equations is when you have more than one equation with more than one variable. Quite straightforward. Also, for example, 3x squared plus 2x minus y cubed equals 7, x plus y equals 3. So this is two simultaneous equations with two variables. Two equations, two variables. Okay. Now, so this is a system of equations, or simply simultaneous equations. The assignment will hopefully today. I'm rereading it today. So today or tomorrow, the latest. Okay. So the question is when is going to be published? It's going to be published today or tomorrow, the latest. So sorry for the delay. Now, if the equations contain only x and y, so for example, x plus y equals 3 and x minus y equals 1, we call this system of linear equations. System of linear equations. Okay, does that make sense? So just system of equations. In this case, it's non-linear. Well, this one is non-linear. The second one is linear. But this one is a system of only linear equations. Linear equations. A linear equation describes a straight line, right? Because these are both equations of straight lines. Linear equations describe a straight line in 2D, of course. Now, okay, that's that. Solving simultaneous equations graphically. So if you want to solve simultaneous equations graphically, you need to draw to solve graphically. Draw the curves, the lines, curves, and the points of intersection are the solutions. And the coordinates. How does that work? Well, let's say you want to solve a simultaneous equation. So you draw x plus y equals 7, 2x minus y equals 5, right? And all you need to do is draw the two lines. So the first line is y equals minus x plus 7. So it's a straight line with gradient minus 1 and intercept of 7, 1, 2, 3, 4, 5, 6, 7. And gradient minus 1, so it's a straight line like this. And the second line is y equals 2x minus 5. So it has a y-intercept of 5, of minus 5. 4, 5, and a gradient of 2. So it's a straight line like this. So this is y. This is equation of this line is x plus y equals 7. The equation of this line is 2x minus y equals 5. And where they intersect as point 4, 3. And this is the solution, the answer. Answer is 4, 3. Or you can say x equals 4, y equals 3. How much sense does it make on a scale of 0 to 10? Do you understand everything so far? 10, 10, 10. How many people? 6 people. Okay, very good. Lovely. If you have system of nonlinear equations, then it's just slightly harder. So for example, x squared plus y squared minus 6y 6y and plus 9 equals 9 equals 0. And let's say y plus y minus 3 equals 0. Okay, so this is nonlinear equation. This is a system of nonlinear equations, but you can still draw them. And I'm going to do it the proper way. I wanted to do it using Desmos, but I'm not going to use Desmos. So this is equivalent. This symbol means equivalent to. This is equivalent to saying y equals 3 and x squared plus y squared. I'm going to complete the square here, minus 6x, or 6y, plus 9. This is a complete square. Now I need minus 9 here. This is equivalent to x squared plus y minus 3 squared equals 9. And this is y equals 3. So this is a circle, and this is a straight line. Okay. We know how to draw circles, hopefully. And is a circle of center 0, 3, and radius 3. So 1, 2, 3, and radius 3. So the circle looks like this. So this has equation x squared plus y squared minus 6y equals 0. The equation of this circle. And the equation of the straight line is y equals 3. That's a horizontal line. Just like this. So the system has two solutions. Which are minus 3, 3, and 3, 3. So the answer, minus 3, 3, and 3, 3. You can simplify it. You can write plus minus 3, 3. Yeah, it's allowed. Does this equation make sense? Does this solution make sense on a scale of 0 to 10, please? So I got 2 10s. 1, 2, 3, 4. Okay, makes sense. But you can also do it using a graph. So x squared plus y squared minus 6y equals 0. And y minus 3 equals 0. Here it is. And indeed, here are the two curves. Had to join a bit late. That's fine. Okay. So all I'm doing is showing you that the link between the graphical solution and the equation. Now, linear equations, as I said, they do not contain squares or any other power except 1. Systems of linear equations, all unknowns are to the power of 1. Unknowns to power 1. 1. Okay, so for example, x plus y equals 3, x minus y equals 7. This is linear equations. But xy equals 3, x plus y equals 7. This is not simultaneous. This is not linear. This is non-linear, linear, and this is linear. Because the power of the variable is 1, 1, 1, 1. Here we have power 2 because we multiply the variables. X times y is power 2. So 1, 1. So linear, non-linear. Okay. How many solutions can a system of linear equations have? How many solutions can a system of linear equations have? Is that the only option, though? System of linear equations can have one solution, of course. 2. How can it have 2? 0 solutions. Okay, so because linear equations, these are equations of straight lines. So if you take ax plus by equals c and dx plus ey equals f, jeez, these are equations of straight lines. So straight lines can cross, and that's one solution. One solution. Straight lines can not cross. In this case, you have 0 solutions. What is the third option? Aditya, can you explain why? You are correct. Aditya said infinite solutions. Can you explain how? Happy to use your mic, but okay, you were correct. It's okay. It's okay if you don't know. Yes, Parichita, you are correct. The lines lying on each other. Exactly. When the lines are, look. When it's the same line. Every point belongs to both lines, right? So any point is a solution. So an example would be the following. for one solution? Well, let's say x plus y equals 9, x minus y equals 5. There's one solution, and it is 7, 2. So x is 7, y is 2. Does that make sense? Yeah? I hope I don't need to solve it. If you solve it, you'll find that x is 7, y equals 2. Single solution. Okay? Now, zero solutions. So let's say we have 2x plus y equals 3 and 2x plus y equals 5. If we subtract the two equations, we get 0 on 2x minus, okay, we get 2x minus 2x plus y minus y equals 3 minus 5. We get 0 equals minus 2. So impossible. There's no solutions. Okay. And you can notice that the coefficients are proportional, are the same. So the lines are parallel. So the lines have the same gradient. So note lines have different gradient. And lines have same gradient. And there's infinity solutions. Infinity solutions when lines have the same gradient and the same y-intercept. Lines have same gradient. So an example of that would be 2x plus y equals 3 and 4x plus 2y equals 6. Okay. So what do I do here? Well, I multiply the first equation by, let's say I multiply the first equation by minus 2. I get minus 4x minus 2y equals minus 6. And then 4x plus 2y equals 6. Then I add the two equations. And what I get 0 plus 0 equals 0. So 0 equals 0, which is always true. Always true for any x and y. So the solution to this, to find the solution, you write down one of the first equation, the one of the equations, to 2x plus y equals 3, and then y equals minus 2x plus 3. So the solution, the answer, is x, comma, minus 2x plus 3, where x is any real number. I have to ask, how well do you understand situation number 2, where we have 0 solutions on a scale of 0 to 10? Okay. On a scale of 0 to 10, how well do you understand situation number 2? No worries. How well do you understand situation number 3, where you have infinite solutions? The notation, what about this notation, where x is real number? What does it mean? Well, it means that any number on the line is a solution. Any number, no, any point on the line y equals minus 2x plus 3 is a solution. No, the answer would be x, comma, minus 2x plus 3. Where x is any number. So these are pairs of points. So for example, if x is 0, it's going to be 0, 3. If x is 1, it's going to be 1, 1. If x is 2, it's going to be 2, minus 1. Minus 1. So we have an infinite number of solutions, but they are all described by this formula. Okay. Any pair of numbers that fit this pattern is a solution. Any pair of numbers is a solution. Okay. Right. So let's practice a little. Problem 3. For what values of k does the system have no solutions? So no solutions, that means that it is case 2. The lines have to be parallel. So we write down the equation. We have, right, ky equals minus 2x plus 5. We rewrite the first equation. The second equation is 2y equals minus kx plus 6, which is equivalent to, we divide by k, y equals minus 2 over k x plus 5 over k. And y we divide by 2 here is minus k over 2 x plus 6 over 2, which is 3. Right. In order for the lines to be parallel, they have to have the same gradient. So this is the gradient of line 1, and this is the gradient of line 2. For lines to be parallel, they have to have same gradient. Okay. So that means minus 2 over k has to equal to minus k over 2. We can get rid of the minuses. 2 times 2 is 4. K times k is k squared. So 4 equals k squared. So k is equal to plus or minus 2. There are two solutions. But they have to have different y-intercepts. So we have 5 over k must not equal to 3, because if these are the same, that means that they have infinite solutions. But because k is 2 or minus 2, that means so k is not equal to 5/3, which is fine. Which is fine because we still have. So the solution is 2. Let's check. Sanity check. Check. If k is 2, then we have 2x plus 2y equals 5, and 2x plus 2y equals 6. Voila. This is x plus y. These are indeed parallel lines, and they, yeah, it's not the same line. So parallel lines. Now, if k is minus 2, a similar situation is 2x minus 2y equals 5, and minus 2x plus 2y equals 6. Slightly less obvious, but they are parallel, because if you multiply this second by minus 1, you get 2x minus 2y equals minus 6. So you can see that these lines are indeed parallel lines. And of course, the beautiful, my beautiful friend Desmos. If I draw the first line, I draw the second line, and I am allowed to change k. So this is the first equation, 2x plus ky equals 5, and kx plus 2y equals 6. And I add a slider for k, so I can move k. And you can see the lines change. So we have one solution, one solution, one solution. They're parallel if k is 2. Beautiful. If k is 2, they're parallel. And if k is minus 2, they're also parallel. Okay. All right. Do you understand the solution to this problem? Okay. Same question. Same type of problem. Now they want to have infinite solutions. So infinite solutions, that means that they have to have the same gradient, and they have to have the same y-intercept. So what we do is we rewrite it as y equals ax minus a, and 2y equals x minus 1. Divide the second equation by 2. So y equals ax minus a, and y equals 1/2 x minus 1/2. So it's quite straightforward, as you can see here. This is only true when they have the same gradient and the same intercept. So A has to be equal to 1/2, and minus A has to equal to minus 1/2. So A has to equal to 1/2. That is the solution. Simple, right? So infinite solutions if A equals 1/2. Let's test that. Ax minus y equals A. So Ax minus y equals A. Add slider, yeah, certainly. And 2y minus x plus 2y equals minus 1. Minus x plus 2y equals minus 1. And minus 5 to 5 with a step of 0.1. And you can see the first line is fixed. The second line, it's infinite solutions, and they match up when A is 0.5. Indeed, works. Okay, moving on. Now, some of the methods will seem weird to you, okay? So this one. Any ideas what we can do here? Any ideas how we can solve this? Yeah, well, the problem with that method, you kind of want to do substitution here, but the problem is that if you try to make, let's say, make y the subject, it's y cubed equals 7 minus x cubed. And then y is cube root of 7 minus x cubed. You're kind of getting in a mess here. Like, it's going to be x squared multiplied by cube root of 7 minus x cubed. I mean, you can do it, technically, but you'll need a whole set of skills to actually solve it. Because solving an equation with cubes and cubic roots is a tough ask. Substitution by first isolate one of the variables. Okay, well, I haven't done this one. Parachita, very nice. X plus y cubed formula. What about it? What about it? Factorize out x cubed minus y cubed for the second one. For the second one, you can factor out You mean xy? You can factor it out and it becomes x plus y equals -2. Sort of, yeah. But yes, Parachita, you're the close. Yeah, graphical method, of course. But honestly, I don't know. I can imagine how to draw the first one. I can't imagine how to draw the second one. It's just like doesn't make sense to me. How would you draw it? Actually, how would you draw it? Let's give it a go. X squared y plus xy squared equals -2. If you're capable of drawing that, you're a better mathematician than me. Okay, I might have been able to draw that, but I mean, honestly, that's like, yeah, I know I can draw it, but I mean, if it weren't for Desmos, it would take me a long time to draw it. I would, I would sit down, probably spend half an hour to draw that thing. So, yeah, but Parachita, yes, you are correct. You need to use the formula for x cubed plus y cubed. So how does that work? Well, you remember, or do you, that x plus y cubed is x plus y squared multiplied by x plus y, which is x squared plus 2xy plus y squared multiplied by x plus y. Or maybe you just remember the cubic expansion, the binomial expansion formula, or the Pascal's triangle. And you know that it is x cubed plus 3x squared y plus 3xy squared plus y cubed. So what I'm going to do is I'm going to multiply the second equation by 3. And I get 3. Wow. So x cubed plus y cubed equals 7. And this is 3x squared y plus 3xy squared equals -6. And now I add the two equations. I add the two equations, and what I get is x squared cubed plus 3x squared y plus 3xy squared plus y cubed equals 1. Okay? And what I get is x plus y cubed equals 1. And that means x plus y equals 1. So we can say that y is equal to minus x plus 1. You can guess the solution, or you can substitute. So it means that it's going to be x cubed plus minus x. Um, Well, I just remember that. I happen to remember that. I happen to remember that this thing. The question is how, why was x plus y cubed was used? Why was it used in the first place? Well, I happen to remember that. Now here I see little bits and bobs. You see x cubed is present here. Y cubed is also present. Now x squared y and xy squared, they are here as well. So by multiplying the second bit by 3, I can construct this expression. And this expression is x plus y cubed. Does that make sense, Dishita? So the reason, because I recognize it. I recognize that there's something fishy going on here. So, and I multiply this by 3 to get this same expression. And because this thing is just that. And if x plus y cubed is 1, that means x plus y has to be 1, because the only number which is 1 when cubed is 1. Therefore, x plus y is 1. And so I can now replace y with minus 1 plus x plus 1 cubed equals 7. And I can expand this. So x cubed plus, so it's going to be 1 cubed minus 3x plus 3x squared plus minus x cubed. I'm just opening these brackets carefully, right? And I'm not doing anything exceptional, just opening the brackets. If you expand, you will get the same thing. So it's going to be x cubed plus 1 minus 3x plus 3x squared minus x cubed equals 7. Bam, bam. X cubed cancels, and we have 3x squared minus 3x minus 6 equals 0. So x squared minus x minus 2 equals 0. And here I can, because I can solve these, so x equals, it's a special case number 2, if you remember what I'm talking about. Because if you replace, so x is minus 1, x1 is minus 1, x2 is 2. Therefore, y1 is minus x plus 1, so it's 1 plus 1, it's 2. And y2 is minus 1. Beautiful. So the answer, minus 1, 2, and 2 minus 1. And it actually makes perfect sense, because if you think about it, this equation is symmetrical. That means if you switch x and y around, the equation would stay the same. It's a symmetrical equation. So the answer has to be symmetrical as well. Okay. So how much time do we have? So yeah. It's an unusual way, usual method, but when solving simultaneous equations, you have to be creative. Maths is a creative activity. So yeah, I hope you enjoyed that one. The next one, have a look at this. So 2x squared minus x plus 3y. So what you can do here is you can subtract. You can subtract the two equations. So it's going to be 2x squared. I don't know that I have to subtract. I'm just giving it a go, right? It sometimes works, sometimes doesn't. So it's okay to give it a go. Minus 2y squared minus x minus y minus 3y minus 3x equals 0. And what you can see here is 2x squared minus y squared. Now these minus 4x minus 4y equals 0. So you can simplify 2. Now this factorizes. It becomes x minus y, x plus y. It's a difference of two squares. Minus 4, x plus y equals 0. Ooh, interesting. I can factorize it even further. I can say that this is x plus y is a common factor. You can see x plus y is a common factor here. Open bracket, 2x minus y minus 4. Of course, you need fluency with algebraic manipulation here. So it's going to be x plus y multiplied by 2x. I might as well just leave it like this. 2x minus y minus 4 equals 0. Equals 0. Right. Now I can say fantastic. I have a multiplication of two values which make 0. So I have two scenarios. Either x plus y equals 0, or 2x minus y minus 4 equals 0. In this case, in the first case, y equals minus x. And in the second case, we have 2x divided by 2, x minus y equals 2. And that means y is equal to x minus 2. And now I can substitute that into one of the equations. So this is a substitution with extra steps. Right, so sub into 1, into the first equation. Okay. Well, I chose 1 because I don't want to square the expression. So it's going to be 2x squared minus x minus 3y, which is plus 3x, equals 0. And then it's super duper easy because we have 2x squared plus 2x equals 0. Now x is equal to 0, or x is equal to minus 1. We have two solutions. x1 is 0, x2 is 0. So if x is 0, then y1 is 0 as well, because it's minus 1. y2 is, if x is minus 1, is going to be 1. Okay, let's check. 0, 0, obviously a solution. Okay. 1 minus 1, sorry, minus 1, 1, minus 1, so 2, plus 1, 3, minus 3, 0, 2 plus 1 is 3, minus 3, 0. Obviously, yes, both are valid. So valid, valid. Now consider the second case. The second case is when y equals 2 minus x. So you substitute that into 1. Sub into the first equation, and you get 2x squared minus x minus 3 multiplied by x minus 2 equals 0. So 2x squared minus x minus 3x plus 6 equals 0. So 2x squared minus 4x plus 6 equals 0. Divide by 2, we get x squared minus 2x plus 3 equals 0. And unfortunately, this is not case, it's not a special case, but neither it is, it has solutions because it is, have I made a mistake? No, I don't think so. Yeah, doesn't have no solutions. No solutions. Solutions. Because discriminant is negative. The discriminant is b squared minus 4ac, which is 4 minus 4 times 3, which is negative 8, which is less than 0. No solutions. So the answer is 0, 0, and minus 1, 1. Okay. Are you happy with these two problems? If I gave you the same problem, would you be able to do both of them? If I gave you the exact same problems, would you be able to do them now? Okay. Exactly, but that's what maths is about, like searching for the tricks, and that's problem solving. This is another example, and we have these in the assignment. We have very similar ones in the assignment. This is a substitution, but not the substitution that you are used to. This is a different type of substitution. It's like substitution level 2. It's a double substitution. What you need to notice is you need to notice that you have x plus y present here, and x plus y is present here. But also, you have x over y here, and x over y here. And that's your double substitution. Double substitution. Let's call them u is equal to x plus y, and v equals x over y. Okay, so, and that the equation becomes u plus v equals 9. And u multiplied by v is 20. All right, so can you guess the solutions? They add to 9 multiplied to 20. Four and 5, yeah. U is 4, V is 5, or you can use this symbol, or U is 5 and V is 4. Can you prove that there are no more solutions? Well, yes, you can. It's a if you substitute, if you make a substitution, U is 9 minus V, it's going to be a quadratic, and the quadratic can only have two solutions. So therefore there are only two solutions. And from here, that means that U is 4, V is 5. That means X plus Y is 4. X over Y is 5. Or X plus Y is 5 and X over Y is 4. Can you solve these? Well, yes, this is not very complicated. X equals 5y. So this is going to be 5y plus y equals 4. That means that 6y is 4, 2/3. Y is 2/3, and x is 10/3. Or, so this means and this means or, just in case you forgot. Here you have x equals 4y. So 5y equals 5. Interesting. Have I made a mistake somewhere? It doesn't look like it. So y equals 1 and x equals 4. I was surprised. Oh yeah, that makes perfect sense because they're not symmetrical. Of course they're not. So the answer is 4, 1, or, well, 4, 1 and 10/3, 2/3. Any questions? I hope I rushed through the last bit a little, but I hope there's no problems here. So double substitution is also a method of solving simultaneous equations. I don't think it's covered in school, but yeah, something now that you're aware of. Okay. I'm embarrassed I forgot how to do this one. But let's test. Let's test me. Okay. It will be very embarrassing if I can't do it. So how would I approach this? Well, what do I see? Well, I see that these two have a common factor. So let's factorize it. Let's factorize this bit. So it's going to be xy open bracket. So 2x minus 3 3y. Okay. What about this one? Well, okay, these two this is called factorizing by grouping. I can take -6 out of the bracket. So -6 as a common factor, and I get 2x minus 3y. Ooh, interesting. And that's equal to 16. Okay, what can I do with it now? Y plus 2. That doesn't work. X minus 3. X plus 1. That doesn't work either. Okay. Oh, yes. I can see it now. Oh, interesting. Oh, beautiful. Yes. And now I can do the double substitution. So double substitution. Do you see it? Did you see the double substitution now? xy plus 2x minus 3y plus 2 equals 0. So u is xy and v is 2x minus 3y. So it's going to be u v minus 6v equals 16. And then u plus v plus 2 equals 0. So from here, I can make v the subject. V is minus u minus 2. So u multiplied by minus u minus 2 minus 6 multiplied by minus u minus 2 equals 16. So from here, minus u squared minus 2u plus 6u plus 12 equals 16. V equals minus 2 minus u. Okay, what do I get? I get minus u squared plus 4u plus 4 equals 0. Now that's not good. So u squared minus 4u minus 4 equals 0. U minus 2, I'm completing the square, plus 4 equals 8. U is equal to 2 plus or minus 2 root 2. And v is minus u minus 2. So it's minus 2 minus plus 2 root 2 minus 2. It's minus 4 minus plus root 2. Okay. I hope I didn't confuse you with the last bit. Yeah, that would make much more sense. Thank you. Yeah. Because, yeah, that's going to be minus 4. And that's plus 4. So that's plus 2, minus 2, and that's equal to 0. That makes that's thank you. U is 2, and that means V is minus 2 minus 2. That's minus 4. Okay. Now reverse the substitution because U is xy. So xy equals 2, and 2x minus 3y equals minus 4. This is another set of simultaneous equations which you can solve. Okay, how do you do that? Well, I'd say, yeah, make this the subject. So y is equal to 2x plus 4 over 3. Substitute that into here. So x multiplied by 2x plus 4 over 3 equals 2. So 2x squared plus 4x equals 6. X squared minus plus 2x minus 3 equals 0. That's special case number 1. So x is 1. X is minus 3. And then y is going to be equal to 2x. So 2 plus 4, 3, 2. Or minus 3. So minus 6 plus 4, that's minus 2. Minus 2 over 3, minus 2/3. And this is the this is the solution. So the answer is 1, 2, or minus 3 minus 2 over 3. All right, so not the end of the world. I managed to do it under pressure. Okay, so yeah, this one is actually really simple. All you need to do is to divide the first equation by the second. So you divide the two equations and you get x squared y cubed over x cubed y squared equals 8. And that means you have y over x equals 8, which means that y is 8x. 8x, and then you could just use that to solve it. So for example, y is 8x. So x cubed multiplied by 64x squared equals 2. So you're going to be x to the power 5. 64x to the power 5 is 2. X to the power 5 is 1 over 32. So x is 1 over 2. X is 1/2. and y is 8x, so y is 4. That's it. That's the solution. And finally, problem 8. Problem 8. Well, it's not a double substitution. Let's see. Let's see what we can do. I also don't remember how to do this. Find the common. No, I think I know what to do. So find the common denominator. So you multiply this by x, multiply this by y, and multiply this by xy. And you get x squared over xy plus y squared over xy. By 6x. Okay. 6xy, 6xy equals 13xy over 6xy. So you're left with 6x squared plus 6y squared equals 13xy. Hmm. Okay, I take the second number and multiply it. Doesn't look pretty. I'm trying to make it. I can solve it from. I can solve it now. I can substitute x, but I'm trying to make it prettier. So take the second equation and square it, and it's going to be x plus y squared equals 25. Expand, and I get x squared plus 2xy plus y squared equals 25. I multiply the whole thing by 6. Why I'm doing that to get this. So you're going to be 6x squared plus 12xy plus 6y squared equals 25. Oh, not 25, of course, but it is 150. So together with this equation, 6x squared plus 6y squared equals 13xy. Now I can subtract. So it's going to be 12xy equals 150 minus 13xy. And I get 25xy equals 150. So xy is 6. So I have xy equals 6, but I also have x plus y is 5. X plus y is 5. at all great lengths, I'm avoiding quadratic equations, but okay, I can solve it now. It's either 2 and 3. X is 2 and y equals 3, or x equals 3, y equals 2. So the answer is 2, 3, or 3, 2. That's it. Could you turn it into 6? Oh, yes, you could. You could turn it to 6. Wait, 6x plus y, x plus x minus y. But no, unfortunately, because that's the sum of squares, not difference of squares. Vishaka is asking, could you turn it in? Can you factorize it? But you can't factorize. You can't factorize this bit because this is unfactorizable. If it was minus, then yes. All right, I'll leave you here. I hope you found something useful today. I will publish most likely tomorrow morning, but maybe tonight. But yeah. Parachita. Well, fortunately, no, because what do you do with x plus y equals 5 then? If you substitute this for u and this is for v, what do you do next? Does that make sense? But you need two equations. You need two equations to solve. To solve for y and u. There's another way of doing it. Well, there are multiple ways of doing it, but yeah, you can sub u is equal to x over y. That won't work because then we have this is u and this is 1 over u. So it's going to be u plus 1 over u equals 13 over 6. Then you can solve for u. So u squared plus 1 equals 6u squared plus 6 equals 13. U 6u squared minus 13u plus 6 equals 0. Oh, u is going to be 2/3, or u is going to be 3 over 2. And there are two solutions. And then you have, because u is x over y, so x over y is 2 over 3, and x plus y is 5, then you can work out x and y. Or x over y is 3 over 2, and x plus y equals 5. You can also work out x and y. This is another method. This is a different substitution. Okay. See you next week. Enjoy.